Okay, so let's discuss about the concept of database indexing. So to understand this, let's take a very simple example of the dictionary. So let's assume that you are given a dictionary where the words are just randomly added. Okay, in that dictionary, let's say there are 1,000 words that are added randomly, and you are given the task to find the meaning of a book, a word called as book. So now how do you approach to find this meaning? So here you need to go through each and every word in that dictionary to just find the word and the meaning. So let's say if there are 1,000, as I said, there are 1,000 words. So in this case, let's assume that the time taken to read each word, let's say 1 second, then you can say the worst case scenario here will be 1,000 seconds, right? So it will take 1,000 seconds to search for every word in that dictionary, right? So now let's assume, let's consider the another scenario where now the dictionary has the words that are sorted, or they are written in the lexicographical order. So that means the first, it will start from A, then B, C, D, right? So like that, as we usually see in the dictionary. So now when the words are in this lexicographical order, now in this case, if you are given the same task, then what you will do, you'll just first directly go to the B index, that is the words starting from B, and from there you will start to find the next word, that is BA, BB, BC, right? So you'll just go to BO, and then you will quickly find the word book and you'll get the meaning. So here the time taken will be significantly reduced, right? So earlier you needed 1,000 seconds because you needed to see every word. So in some case you may have found it earlier, but in some case you may needed to go till the last word. But now when the words are in a sorted order, as you know, we'll definitely get it in a more quicker manner than in the unsorted order, right? So this is what exactly the concept of database indexing is. Let's take a real example to understand that. So here, let's say I have a table in the SQL database with 3 columns, that is ID, city, and grade. So in the ID, I have the student ID. In the city, I have the different cities and the grade of that student. Okay, so now here, let's say the first task that is given to us is to get all the students whose ID is greater than 5. So now in this case, when we execute a query to select all the students whose ID is greater than 5, in that case, the operation that the database needs to do is very simple, right? Because here the ID column is already indexed, or it is already sorted. So it will just select all the rows that are greater than or equal to 5, and that will return us back, right? Because here the ID column is already indexed, because the ID column is a primary key. That's a primary column, or the primary key column, which by default the database will automatically index it. It will keep all the values in the sorted order. But now let's say we change the query where the query is now that get me all the students who are from Delhi and whose grade is greater than 80. Okay. So now in this case, just assume how much processing the database needs to do, because here the cities are not in the sorted order, right? The Delhi city may be present in the first row, or it may also be present in the last row, right? So now in this case, what the database needs to do, it needs to check each and every row where the student's city is Delhi. Okay. So first it needs to get all the students whose city is Delhi, and then it needs to go to the next column, that is grade, where now it has to remove or filter out all those rows where the grade is less than 80, right? So now whatever it is left, then that it will return us back. So from the time complexity point of view, it is O of begin, right? Where it needs to look at every row present in the database, right? So now how do we resolve or overcome this issue and increase the performance? So for that, we can implement the indexing concept that we just discussed. So that is exactly what we'll do here, where we will index these 2 columns. So we need to run a indexing operation or a command in the database to index these 2 columns, that is city and grade. And then once it index, what it will do, it will just sort the cities in the lexicographical order, and it will just store it in this way. And then it will then sort the grades accordingly within the cities. So first it will sort according to the cities, and within the cities, let's say Delhi, it will then again sort them on the basis of the grades. So finally the index will look like this. So basically these index will be stored in something called as B tree. So here B stands for balanced tree. This is a similar concept of a binary search tree, where in the binary search tree we will have a root node and 2 child nodes, and every child again will have the child nodes, right? So where we only have two child nodes, but here in the balanced tree, we can have multiple child nodes, but at the end it will look a balanced tree, where finally the data will look something like this once the indexing is applied on these two columns, right? So I hope you are able to understand how the data will look like in the B tree once it is indexed. Now let's come back to our same query. So now once we execute the same query where we need all the students from Delhi whose grade is greater than 80. So now what the database will do, it will first check whether there is any index applied on these two columns. So it will see that there is already an index applied. So instead of directly checking this table, first it will go to the index B tree, and then it will first directly go to Delhi. Like it's the same way, the way we search for a word in the dictionary. In the same way, the database will search for Delhi. Okay, first it will search for Delhi in this sorted order. So it will first go to Delhi, and it will just get all the rows of Delhi, and then from there it will just sort out all the rows that are less than 80. So it will just get all the rows which are greater than 80, and then for those rows it will get the index, that is the ID. So it will just get those IDs from these from the main table, and it will just return us back. So getting those rows with the help of ID will be an operation of big O of 1, that is constant time complexity, and the overall operation will be of big O of log n, right? Because now here the database do not need to scan all the rows in the table, but it just need to get the rows from the index, and then with the help of 1, it will just get directly those rows, and it will return us back, right? Okay, so I hope you were able to understand the difference here when we applied the indexing and when there is no indexing on particular columns. Okay, so now we have just discussed this theoretically. Now let's look at this practically, how it will make the difference. Okay, so here let me first create the table. So I have created a student table with the ID, name, age, city, grade, and enrollment date. Okay, so here I have created a stored procedure that will just randomly add around 1000 rows with these data. Okay, so let me just create this procedure and run it. I'll share you all this database command in a GitHub repo, and I'll share that link in the description. Okay, so we have the student table and some data in that. Let me check. Okay, so we have the data where we have around 1000 rows. Fine. Now let's see how the difference it will make before the indexing and after the indexing. So right now we have not created an index on the city or the grade column. So when we do not have it, if I run this query now, that is a select query where I want the students from city Delhi whose grade is greater than 80. Okay, so if I execute this, so right now it is giving me some data related to this query. So let me just copy it and let me just paste it over here for further reference. Before that, if we run this, so we got this data. Okay, and now what we'll do, we'll apply the index. Okay, so we'll apply the index on these two columns. Okay, so once we add this index, internally the database will create the B tree and store the data in this format. Okay, and post that we will again run the query and we'll see the difference. Okay, so let me just run this. Okay, so the index has been created, and now if I run the same query, we will get the query explanation, and then now if I paste it here and analyze this, we will see that. Okay, so here if we analyze the first query or the first output, here what does it say? It has applied these two filters, that is the city should be Delhi and the grade should be greater than 80. Okay, so when this filter was applied, it received total 68 rows. Okay, and to get to this output, what does it did? The database scanned total 1000 rows. That means it has scanned the whole table, because the table has total 1000 rows. So it scanned the whole table, and it took around 8 milliseconds. Okay, so for this is the result when indexing was not applied. Now post when the index has applied, here you can see the index range scan on students using these two index. So it has used city and the grade. So the other two index it has used. Okay, and here the total rows it scanned was only 68, and it took around 0.4, like that is 4 milliseconds. So that's around 50% reduction in the total time. So right now here we just have 1000 rows, right? But in production systems, there will be millions of rows, and in such condition, the amount of performance improvement will be significant, right? Because this will reduce a huge amount of time when we index certain columns. Okay, and here which columns to be indexed, that again will be depend on the requirement. Okay, so I hope you were able to understand the essence of indexing and how to implement the indexing, and how does it make the difference. Okay,